A wildlife biologist told me the ground was dead. Eastern Kentucky's stripped coal fields, bare spoil rock, acid soil, nothing. Between 1997 and 2002, the state trucked in 1,541 elk from 6 western states and turned them loose on it. No seeding program had fixed that land. No reclamation budget had. 4 hooves and bare rock. What happened next? Built the largest elk herd east of the Mississippi. 1,541 elk, dead ground. The eastern Kentucky coal fields were not empty the way a forest is empty in winter. They were chemically finished, compacted overburden, pressed down to a density that roots could not penetrate. Acid leached through every surface layer. No seed bank survived in that substrate. No canopy had returned to hold moisture. There was no grazing animal to move anything, no hoof to break the crust, no gut to carry seed from one slope to the next. State wildlife managers had spent years inside that argument. The question was whether any large ungulate could survive on reclaimed mineland at all. Most of the people in those rooms said no. The land had 3 strikes against it. The substrate was compacted beyond normal root penetration. The acid chemistry repelled most pioneer plants. And a century of mining had stripped away every remnant of the original seed bank. I'm Dr. Raymond Finch, and I have followed this recovery for longer than most people know it exists. What the field teams documented in those first seasons on the spoil is not what anyone in those rooms predicted. The trucks arrived, the gates opened, and the elk did not wait for a plan. They moved straight onto the bare spoil and began doing what a 700-pound animal does. They walked it, broke it, and passed through it. Each hoof strike fractured the compacted crust. That fracture let water infiltrate instead of sheet off. A single herd crossing a slope once left a pattern the ground had not seen in over a century. The land that a century of industry left for dead was still holding a charge. It just needed the right weight walking across it. Nobody paid for that. Within the first few seasons, pioneer grasses appeared along the exact corridors the herd used most. The spoil had not been reseeded. No contractor had touched it. The animals had, but the field teams kept finding something they could not immediately explain. The densest vegetation patches were not on the gentler slopes where the elk rested. They were on the steepest, most degraded ground the herd crossed at speed. From a car window on Route 119, the eastern Kentucky coalfield looks finished. Grass-covered benches, softened ridgelines, nothing that would make you pull over. That impression is the most expensive lie the reclamation era ever told beneath that grass cover. The surveys found something closer to concrete than soil. Root systems could not push more than a few centimeters before hitting compacted overburden, packed so tightly that water sheeted off instead of soaking in. In Pike County, in the heart of the coalfield, thousands of hectares carried a grass cover with almost no native woody species establishing beneath it. The surface looked stable. Nothing was breaking through. Across Breathitt County, streams running off the grades carried sediment loads the aquatic invertebrate community could not recover under. Without a grazing animal aerating the margins, the bank structure stayed sealed. Water moving through, life locked out. In Knott County, mandatory reclamation fescue had become a monoculture ceiling. It crowded out native forbs, starved the insects that depended on them, and, with no hoof to break the sod, held its position without challenge. Letcher County told the same story at a different scale. The transition from compacted bench to functional grassland had stalled. not for lack of nutrients, but because nothing alive was doing the physical work of moving them. The elk had been absent from Kentucky since the late 1800s. That absence ran longer than anyone still working the land could remember. The entire eastern range had reorganized itself around a missing gear, and nobody had noticed because the grass grew back anyway. This is the part that made me stop and reread the field notes. The biological stasis came down to the same three absences everywhere. No native seed stock surviving in the profile, no browsing pressure to open the sod, no large body moving nutrients across the slope. What no survey predicted was that the steepest, most punishing terrain, the slopes the elk crossed at speed rather than rested on, would show the densest recovery. Nobody had a model for that. The mechanism the field teams kept reaching for kept slipping just out of reach. Something was happening under a running hoof on hard terrain that was not happening anywhere. The animals slowed down. The answer was in the physics of impact, and it would rewrite what reclamation science thought it knew about weight, speed, and soil. A hoof landing on compacted spoil at a run does not simply press down, it twists, shears and releases, punching a narrow column of disruption through the sealed crust that no roller or tine replicates. That column fractures the capillary seal. Air enters. Water follows a different path on the next rainfall, and the microbes that aerobic decomposition depends on find oxygen they have not had in years. The surveys recorded the result without isolating every step of the chain. That is the honest read. But the physical sequence, impact, fracture, aeration, microbial recolonization, is not invented. It is textbook soil mechanics applied to a living animal. Mandatory reclamation seeding under federal law had stabilized the overburden. It covered the wound. But stabilized ground and recovering ground are not synonyms, and the difference is everything a plant needs to put a root down. I'm Dr. Raymond Finch. What I watched across those grades was a three-part failure. The seeding held the surface, but could not aerate the substrate beneath it. The erosion controls slowed sediment, but could not rebuild the invertebrate life the sediment had buried. And no machine then or now can deposit the dung that seeds a fungal network into bare spoil. Wildlife managers in the late 1990s raised real objections. Disease transmission to livestock, questions about whether spoil bench habitat could carry a herd of any size. Those were reasonable concerns. Then the animals arrived. The machinery had stabilized the damage. The elk began reversing it. Within the first few grazing seasons, monitoring crews were writing down changes the engineering budget had never produced in years of managed work. A 300-kilogram animal walking the same ground daily delivers a magnitude of compaction-breaking force no aerator blade matches. And it does it selectively along the exact routes where pioneer species later established. I have followed this recovery for longer than most people know it exists. And the question that kept the monitoring crews up, the one still without a clean answer, is why the wallow sites, those bare, wet patches the elk scraped into the spoil, are now outpacing every other recovery zone on the grade. A wallow is a wound the animal opens deliberately. Bare, wet mineral soil, exposed to light, colonized first by the species that need no competition to establish. What comes up in that patch in the second and third year is not what the reclamation seed mix ever put there. The law gave Kentucky the tools to hold the damage in place. It took a living animal to run the system the other direction. Nobody wrote a budget line for that. Hooves punched through compacted fescue. That is where the sequence started. Not with a management decision, but with the physical fact of a hoof strike. Each strike concentrated the weight of a draft animal onto a point the size of a hand. The fescue mat cracked open. Water that had been sheeting off the bench slopes began infiltrating instead. Within the first growing seasons, monitoring crews were recording native Hooves species in the disturbed patches. No management program had seeded them. Nobody planted them. They came up through the breaks the herd had made, then the dung. Elk deposited it in volume across a range, and dung-associated beetles and fungi moved into the coalfield counties behind the herd. Decades of compaction had locked organic material out of the soil column. The beetles began unlocking it. The sequence the herd ran was 3 steps no machine had managed. Infiltration through hoof puncture, organic processing through dung fauna, and standing water through excavated wallows. Those wallow margins held water through dry spells. Invertebrate communities began rebuilding in the wet edges. Where invertebrates rebuilt, the birds that tracked them followed. Wild turkey populations climbed in the release counties as grassland structure diversified. Songbird species tied to open-ground forb patches began appearing in survey transects across areas that had recorded almost none before. Then the cascade ran past every boundary anyone had drawn around it. The herd moved into surrounding forested hollows and ridge margins. Their browsing pressure opened the mid-story canopy. Light conditions at the forest floor changed, and what grew there changed with them. By the time this herd became the largest elk population east of the Mississippi River, it was doing ecological work across a mosaic of land types the original restoration model had never included. Some of that overflow created real friction. Elk moved onto private agricultural land, grazed crops, broke fencing. The interactions between a herd of that scale and small-scale farming operations in the hollows are documented. They are not trivial. The recovery did not stay inside its lines. I've followed this long enough to know that is not a failure of the plan. That is what a functioning herd does when the landscape has the capacity to carry it. The question is what the people who farm those hollows make of it. The farmers in those agricultural hollows are not a footnote. Their friction with the elk is documented, county by county, and it is real. But so is the thing sitting just above their fence lines. A living system that repaid no salary, filed no recovery invoice, and asked no county commission for permission to come back, remove the pressure, return the animal. The system does not need to be told what to do next. That is biology, not hope, not luck. Following the same physics it has always followed on every stripped hillside and every acid flat it was ever given the chance to work on. I have watched this recovery for longer than most people know it exists. What I can tell you is that the ground the industry declared finished, the benches, the spoil, the compacted overburden, that ground was never consulted on the matter. The counties that fed America's furnaces were handed the wreckage when the seams ran out. Nobody came back with a check. Nobody came back with a plan that matched what the land was actually capable of doing. What came back instead was an animal, and the animal was enough. What started as 1,541 animals on dead ground is now the largest elk population east of the Mississippi River, on land that every projection said could not carry it. The models were wrong. The land was not. Share this with someone who still believes the damage is permanent, because the evidence from these counties says otherwise. In the most blunt physical terms available, hooves on bare rock. And 20-some years later, a forest floor with something living in it again. Drop your region and one species you have personally watched disappear from your area in your lifetime. And yes or no in the comments, have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. The ground that carries the elk today was not written off by the animals, only by the people who had stopped watching it. The next film goes to the Florida Everglades, where the American crocodile dropped to fewer than 300 individuals before a program began rebuilding the coastal brackish zone the species requires. 300! The US Army Corps of Engineers spent decades managing water flow in that system in ways that actively worked against the habitat the crocodile needed. When the hydrology was partially restored, what happened next was a result the models did not predict.